Europe, the continent that ruled the world's wealth for centuries. Yet, despite all that power, imagine Europe bowing before Russia for its energy needs. For years, Russian gas kept European homes warm, and Russian oil kept its vehicles running. But now, that same Europe is taking steps that could permanently change global energy politics. Yes, you heard that right. Until 2022, around 45% of Europe's natural gas came from Russia, and until 2018, more than 70% of Russia's oil exports were going to Europe. But today, Europe is moving toward becoming energy self-sufficient. To break free from Russia's shadow, Belgium has taken a step that you may never have imagined. Belgium is building an artificial island. Massive blocks weighing 22,000 tons each will be installed, and millions of tons of gravel will be poured into the sea. The project will cost nearly 7.8 billion euros. But the real question is, why? How can an artificial island boost energy supply? And how can it help Europe escape Russia's grip? To understand this, we need to look at the story in detail. Energy supply is crucial for any country. But for decades, European nations depended heavily on Russia for energy. At the same time, the United States kept imposing sanctions on Russia, and Europe often ended up paying the price. To avoid this problem, one European country decided to take a bold step. That country is Belgium. Belgium wants to make Europe energy self-sufficient and free it from Russian dependence at any cost. That's why Belgium decided to build a full-scale artificial island in the middle of the sea. This island will spread across 15 acres and will act as a major energy source. Now you might be wondering, how can an artificial island boost Europe's energy supply? The answer lies in green energy. Europe now wants to move away from natural gas and oil and focus on offshore wind energy. Over the sea, winds blow stronger and more consistently. This continuous wind is set to become Europe's new energy backbone. That's why the European Union set a target of at least 60 gigawatts of offshore wind energy by 2030, and 300 gigawatts by 2050, a target that has since been raised even further. Belgium is set to become a leader in wind energy. In the Princess Elisabeth offshore zone, a wind farm with a capacity of 3.5 gigawatts is being developed. To put this into perspective, this single project will supply electricity to nearly 3 million homes. Sounds impressive, right? But the real challenge begins once the turbines start generating electricity. Wind turbines generate AC, alternating current. And as you may know, transmitting AC over long distances, 50 to 60 kilometers or more, leads to major power losses. That's why AC must be converted into DC, direct current. This requires expensive offshore substations and HVDC, high voltage direct current, cables to bring electricity to the coast. But HVDC cables are extremely costly. Even if wind turbines generate power at sea, each country would still need its own grid system and then connect it to its national grid. Otherwise, if Denmark has excess wind power, that electricity would be wasted while neighboring countries face shortages. Everything was technically connected, but there was no unified system. Europe realized that without a fully integrated grid, it would never achieve its climate and energy goals. This is where Belgium introduced a game-changing idea, the artificial island called Princess Elisabeth Island. This island will not only connect Belgium's offshore wind farms but also link the power grids of the UK and Denmark. This means when one country has excess electricity and another faces a shortage, energy can be easily shared. That's why the location was chosen very carefully, about 28 miles off the Belgian coast. Building an island in the middle of the sea is no easy task. The construction has been assigned to global dredging giants like Jan de Nul and Demi. First, soft seabed sediment will be removed. Then the surface will be leveled and reinforced with gravel to create a strong foundation. This site will become Europe's artificial energy hub, one that could reshape the continent's energy future. But this project is far from simple. Sea waves can rise several feet high, and storms make conditions even more dangerous. That's why engineers created a scale model, 60 times smaller than the real island. They tested it against waves as high as 26 feet, waves that occur only once in 1,000 years. And yet, the model remained stable. This confirmed the reliability of the design. Construction began in 2024. The first caissons were transported to the sea in 2025, but 21 massive blocks are still pending. Each caisson weighs about 22,000 tons. Once placed in a circular formation, the enclosed space will be filled with nearly 106 million cubic feet of sand and soil. When complete, the island will span 15 acres. However, while the physical construction may be completed by 2026, the full electrical system, including substations and cable networks, is expected to become operational between 2033 and 2036. And challenges remain. Initially, the project was estimated to cost €2.2 billion. That figure later rose to €3.6 billion, without including cables. Eventually, estimates climbed to €7 to €8 billion. Due to inflation, supply chain disruptions, and technical constraints, the project's final cost has become uncertain. Even contracts for DC equipment have been delayed. Construction continues, but key electrical installations are currently on hold. Still, one thing is clear. If Princess Elisabeth Island succeeds, it will redefine Europe's energy landscape. It won't just support Belgium, it will strengthen the UK, Denmark, and the entire continent against geopolitical shocks. Experts believe the experience gained here could also help Germany's ambitious AquaVentus project, Europe's green hydrogen dream. AquaVentus aims to transform vast areas of the sea into the world's largest green hydrogen production zone. Using offshore wind power, water will be split into hydrogen and oxygen through electrolysis. The advantage? Electricity is difficult and expensive to store. Hydrogen, on the other hand, can be stored in large quantities and transported over long distances. That's why hydrogen is often called the fuel of the future. By 2035, AquaVentus aims to achieve 10 gigawatts of electrolysis capacity and produce 1 million tons of green hydrogen annually, enough to transform industries like steel, chemicals, and shipping. Challenges remain here too: funding, technology, and regulatory approvals are major hurdles. Pilot projects have already faced delays. But despite everything, these projects remain central to Europe's long-term energy strategy. Because when geopolitical tensions rise and energy supplies are threatened, projects like these will determine Europe's resilience. So the big question remains: will Belgium's Princess Elisabeth Island and Germany's AquaVentus project be completed on time? Or will these billion-euro dreams remain unfinished? Let us know your thoughts in the comments. If you liked this video, don't forget to like, share, and subscribe to the channel.